Hello everyone, in this video I will show you how to set up a Lumera Validator node. I'll be following the official guide, so let's get started. First, you need to make sure your hardware meets the requirements for running the node efficiently. There is a minimum set of hardware requirements as well as recommended set. Of course, having more CPU, RAM, and storage will give you a smoother experience in running the validator. You will also need a Ubuntu server version 22 or later for everything to work correctly, and you will need some Loom tokens, but we'll get to that later. There are two ways of setting up your node. You can use the one-shot automated setup script hosted on GitHub, or you can follow the manual step-by-step process yourself. For this video, I will walk you through the step-by-step. First, connect your server. If you're running an Ubuntu on bare metal, just open up your terminal. I'm already in mine, so I'll start upgrading my system. The system has been updated. Now I will install the required packages so the node can run smoothly. All the necessary packages are now installed. One thing to note is that if you run into a connection issue during the upgrade, you should kill the unattended upgrade process and start the installation from the beginning. Next, we need to make sure we have enough RAM. Let me check my available memory. I have 28 gigabytes of free RAM, which is more than enough. If you don't have that much free RAM, you can create a swap file to add virtual memory. Just allow the 5 lines shown here. For now, I will skip this step. Now we will need to install Go. I'll download the Go binaries, clean up any previous installation, and make sure everything is set up correctly. Then I'll add Go to my shell profile so I can call it from anywhere in the terminal. Let me verify the installation. As you can see, I have Go version 1.23.4 installed. Next, we will need to build the Lumera binary from source with a one-line patch. I'll clone the Lumera repository from GitHub. Then I'll check out the latest version and apply the patch. Now I will build the node from the binaries. This might take a little while. The build is complete. Next, I'll restore the patch and verify it. This is the moment of truth. Let me check if Lumera is installed, and it's built successfully. You might expect to see a version number here, but sometimes the Lumera version command does not display one. That is a known issue. The important thing is that it didn't throw an error, which means we're good to go. Now I'll initialize the node. I'll give it a name. I'm going to call mine light node. This will be the name of the node that will soon become a validator. Next, I'll download the Genesis file into the node. One very important thing, always create a backup of your keys. They are critical. I'll create a directory called Lumera Key Backup and copy my keys there. It is strongly recommended that you also copy your keys off the server to a secure location. These keys are your validator's identity. If you lose them, you lose your validator node. So please take a moment to back them up immediately. Now I'll continue configuring the node. I'll set a minimum gas price to 0.05. If you want to save disk space, you can prune old state data, but I'll skip that for now. You can also enable Prometheus for metrics, which I'll also skip. Next, we'll sync the node by using a snapshot. There are two ways to sync. You can sync from the Genesis block, which takes 3 to 4 days, maybe even more depending on when you're watching this video, or you can download a snapshot and start from there. I'll go with the snapshot approach. I'll reset the data directory and download the snapshot from Pikachu's Lumera snapshot page. Note that the snapshot version changes frequently, so I've included the link for you to find the latest one. The snapshot is about 33.4 gigabytes and will take around 6 to 7 minutes to download. I'll wait for it to finish. Always make sure to use the latest available snapshots so your node can sync as quickly as possible. Now that the snapshot is downloaded, I'll create the systemd service file and add the required values. Then I'll reload the daemon and enable the Lumera service. It's the moment of truth. Let's start the node and see if it runs. It started without any errors, so we're good. Let me check the logs. As you can see, the node is communicating with other Lumera nodes. I'll stop tailing the logs for now, but the node continues running in the background. If I check the status, I can see that catching up is set to true, which means the node is syncing from the block height where the snapshot left off. I'll wait until catching up becomes false, meaning our node is fully synced and up to date. Now that the node is synced, let's set up the firewall to protect it from malicious attacks. First, I'll deny all incoming requests, then I will allow all outgoing requests. Next, I will allow SSH so we can connect remotely, and I'll open port 26656 for peer-to-peer communication with other Lumera nodes. Finally, I'll enable the firewall to make sure it is active on system startup. One important note, don't expose port 26657, the RPC endpoint, unless you specifically need external RPC access. An attacker can flood your RPC with requests and DDoS your node, so be cautious with that. Our node is fully set up and synced. Now it is time to create the validator. First, I'll set up the keyring backend and create a wallet. This is a very important step because it generates your validator keys. If you lose these keys, you could lose your validator, or worse, somebody could use them for a malicious purpose. Please make sure these keys remain private and secure. They are the only way to recover your account. I can now see my wallet address and my operator address. The wallet address is a standard Lumera address, while the operator address starts with Validator, so it is easy to tell them apart. To become a validator on testnet, you need at least one Loom token. You can get tokens from the Faucet website or by asking on Discord. I already have some tokens in my Kepler wallet, so I'll send them from there. Let me check my balance. I have 1.2 Loom. Now I will set up the validator key and set up the validator configuration file. The validator moniker should be the same name as you want for your validator. I am keeping mine as light node. I also set the commission rate, which is the percentage you take from the rewards that are accrued from the delegated stake. I am setting mine to 15% to make it more interesting. The minimum self-delegation is 1 Loom. You can adjust all these values to your preference. Now I will submit a create validator transaction. This is the command that officially turns our node into a validator. I'll paste it and run it. And there it is, code 0, which means the transaction went through successfully. We now have a validator node. Let me verify by running a quick check. As you can see, all the configuration details are here. If you want to be completely sure, you can also go to the Stake Explorer. Under Inactive Validators, you should find your node. And there it is, light node. That's it. We've set up a Lumera validator by following the official guide. From here, you can perform various operations like restarting or stopping the node. Everything is documented in the guide. One thing to watch out for is that you can get jailed if you fail to sign a block or if you double sign. If that happens, you can run the unjail command. You can also check your missed blocks by using the command shown here. The documentation provides a detailed walkthrough of what each command does, and I've left some useful links for you to check out. Thanks for watching.